Okay, so no one's here, but I'm just gonna pretend like people are here. And so I'm going through this book, The Elements of Computing Systems, by Noam, Nisan, and Shimon, Schocken. And it's a really cool book. You go from, the informal name for it is Nand2Tetris, because you go from NAND gates to other gates and so forth to virtual machine, like a computer system, and then you do like a virtual machine. And I thought it would be cool. Well, I've always wanted to, I think I did like 5 chapters of the book like 8 years ago or something, and I thought it'd be cool to just like actually go through the whole book, and why not live stream it at the same time and like try to make everything very visual. So we'll see how it goes. And all right, I'm just gonna get started. All right. All right, so this is Bitwig. This is music production software, but it has this really aesthetically pleasing graph editor for making modular synthesizers, and there's logic gates, and it can do math and things like that. So basically, these are my inputs. I have basically 2 bits, and this is my fundamental gate, the NAND gate, and so we're just going through all the options, the combinations of each bit with. So it's 2-bit inputs. You can have a 1 or a 0, and so this is showing that for none, 1, 1, and for those first 3 inputs to a NAND gate, you get a 1 as an output, and I'm using this VU meter as my output. And then for the final case, where we have both on inputs, we're going to have an off output. Okay, so I'm just going to go through this list and try to implement these other fundamental gates in NAND gates. Okay, so I'm just gonna, my first gate that I want to implement is a NOT gate. So here we go. So I'm just gonna, well, you know what, I'm gonna duplicate this, and then we're gonna make it have just 2. And then I'm gonna duplicate this. Whoops. There we go. Okay, our NOT gate is functioning, and I think I want to add some space here, just so it's clear, like we have our inputs and our outputs, and our work is happening in between. And maybe I want to spread it out a little bit more, just so that we're using the full width of our grid here. So the NOT gate is really easy. We just want to pipe both of our inputs in, and then I'll just duplicate this. Okay, that one was easy, and looks like it works. And then I'm just going to copy this for my other And then I'm just gonna change this to, I think next we want to do and. So we see that and is true when both the inputs are true. I think this one should be pretty easy. Do I want more space? I think maybe it's a little confusing. We'll cross that bridge when we get to it. If I start running out of room. Okay. So I think for an AND gate, I just want to use my, and yeah, should I just consider my NOT gate complete? Maybe I want to color code it. So I think, yeah, maybe just like show that this isn't, should I use blue or red? I think red, maybe red, and then like just leave it yellow for my implementation. I think that works. Color code it. So I think for this one, I'll just, since I already completed a NOT gate, I'll just use I'll just use the foundational gate from, or the built-in gate from Bitwig. Since this book is really about like abstractions and interfaces. So I recreated my NOT gate and now I have it and I can use it to implement gates down the road. Okay, so we've got our AND gate. All right, we're doing an OR gate. All right, starting to get a little more challenging. Whoops, I don't remember this one off the top of my head, so I'm gonna have to think about it. All right, OR. So I think if I NOT both my inputs and then I put them into an AND gate, well, yeah, I think, and then I NOT the output. I think that'll work. I don't know. So let's see. So I think, yeah, I'm gonna start by NOTing both my inputs, then going into an AND gate, and maybe just move these over. And then NOT the output of that. Okay. We're starting to get interesting here. All right, now we've done an OR. I think we need to do XOR. So I'm gonna copy this. And then I want to do XOR. So I am going to bring in my red XOR. All right, so when either, but not both, of the inputs are true, the output is true. So I think I'd like to start with when both inputs are true. I would say maybe like put this into an and with, well, so I think I'll use an or. Okay. I think, yes. Okay. I think when either, so when this bit, the first bit or the second bit are true, my output is true, but not when both of them are true. So I'm going to use the and to say not when both are true. I think that's it. All right. So so I know this is like logic, and it's evident how I got there. In this case, I broke it down. All right. YouTube says I should use a stream of 6,800 kilobits per second. But I think I'll worry about that next time I stream. It's fine. It's fine for now. So what was I saying? I was saying the reason this works is because I broke it down into concerns. So my first concern was that when they're both true, I want it to be a false output. So I'll just pause it here. And so we can see, like, by using the and the not, oh, I guess I could just use a Nand there, but let's keep going with this. If you use an and a not, then when both inputs are true, my output from the not will be false, which is what I want. And then my second concern was that when either input is true, I want my output to be true. And then I'm using, so because I split them up and I had like, basically I reduced the problem to components. Now I have to add in a way to like merge the results. So that's what this AND gate is doing here. But I think I can replace this with a NAND gate and get the same result. Yeah, I will just double check that it works. Yeah, so so I feel like this is very it's a complexity is layers of simplicity, and that's what this book is all about, like taming complexity through interfaces, and which is a synonym for abstractions. Okay. All right, so okay, this is getting interesting. So our next gate is a multiplexer demultiplexor. Yeah, so let's see. Okay, so I think I have a select gate, and I'll just zoom in here. All right, this one might require some some modifications. Yeah, I'll just copy one of these. Because in our case, I think this selector is general purpose in Bitwig, but for our purposes, we're going to treat it like just a bit selector. Yeah. So I'm going to need I think I'm going to go back to 4 on this one. Oh. Well, let's think about it. I could yeah, I guess. What kind of inputs do I want? I think maybe like I think that works. But we kind of want this one to be on. I'm going to look at the, okay, they gave it to me here. Okay, so I actually need this to be 8. So, and our pattern looks like 0, 0, 1, 1, 0, 0, 1, 1, like that. And then I want 0, 1, 0, 1, 0, 1, 0, 1. And then our output should be zero, zero, one, one, zero, one, zero, one. And I think I need to slow down my clock here. And you know what, maybe in this case, I'll just use a oscilloscope. And then I can, yeah, I can just, make my own selector a different color. Okay, I think that'll work better. Okay. All right, that looks good. Maybe I want like a trigger so that we maybe just like a gate length so that it I'm gonna make this all right. Yeah, just so, yeah, and then I can increase it back to, I think that makes a little more sense. And I'm going to keep this with the display. And yeah, we can see like the pulses where it's on. I don't know. No one's watching this, so it doesn't really matter. It just matters for me. Okay, let's see. Yeah, I think that works. I like that. Okay. So that's great. All right, so multiplexer. So you basically have two inputs and you're selecting one of them. So to me that feels kind of like an AND gate. So maybe it'd be like this. And then yeah. And then I'll use I think this is more clear when I can use a not and for this one. So when it's 0, it's going to select the first one. And when it's 1, it will select, wait. Okay, yeah, I got mixed up here. So I actually, I think dog's barking. What I want to do is copy this. I think the crossed wires are getting a little confusing. So I'll just copy this. Oops. And so I think for since when the selector is 0, I want to say choose the first bit, and then when the selector is 1, I want to say choose the second bit because we're using zero addressing. And then I can just OR these and okay, I don't like that. Okay, so now we can see maybe I just want another one of these. So I'll just I'll see if I can't shrink it, but I'll just duplicate this one, and there we go. And they're identical. So we successfully created a multiplexer, and my partner is home, so I am going to go talk to her. Okay. Well, I think this is pretty fun. I'm gonna keep doing this, but maybe Maybe I'll tell people about it next time. All right, how do I end the stream? I could just do it here.